Hello everybody, welcome to your section, or Unit 2, Section 4, Chem Talk Part 1. I know that's a lot to handle. Just know that there will be two Chem Talks for this section. This first one is going to be on types of chemical reactions, so after watching this video, you should feel comfortable looking at a chemical equation and being able to identify what type of reaction it is. And then our next Chem Talk video that you'll see later this week is going to be on balancing chemical equations, and that's going to take some practice, so don't get frustrated if you don't get that right away. Alright, but without further ado, make sure you have your green sheet out and open. You want it to open to page 10, reaction types and chemical reactions. So click that continue button once you are ready. Let's get started. So there are 5 types of chemical reactions that we will talk about in this class. The first of which is the synthesis reaction. We also call this a composition reaction. We will mostly call this a synthesis reaction in our class, and that's mostly because of the letter it starts with. When we go to abbreviating these, there could be a couple with a C, so we want to call this synthesis and think of it with an S when we abbreviate. Decomposition reaction. This is when we are breaking something down. We'll talk about that more in a little bit. We would abbreviate this as a D. So maybe it might be a good idea to write next to these or to the left of the bullets what our abbreviation would be. So our abbreviation for synthesis would be S. Our abbreviation for decomposition will be D. Our next type is a single replacement reaction, and our abbreviation for that would be SR. Double replacement reaction is our fourth type, and our abbreviation would be DR. And then our fifth and final type of reaction is a combustion reaction, and we will give this the abbreviation C, right? And you'll see this is why we call the first one synthesis reaction, just for abbreviation purposes mostly. Alright, so you should have all 5 of those listed, plus the abbreviations. Let's talk about our first type, a synthesis or a composition reaction. So this is when 2 or more substances react to form a single more complex substance. Right? We're starting with 2 small things like you see in our picture here, right? And they will come together to make one more complex thing. All right, we are composing things together. Right, remember we talked about composite materials. Composite materials are where we take 2 things and combine them into one thing to increase the strength and durability. Right, similar word, right? Composition. We are putting 2 things together to make one more complex thing. And our example, first one, we have mercury plus oxygen. Right, Hg is the symbol for mercury, and that produces mercury oxide. All right, so we go from having 2 elements, right, react them together, and now we have one compound. Our second example, we have tin, which is the abbreviation SN, plus oxygen, and those 2 elements will combine together to produce tin oxide, which is a compound, right, more complex than before. A decomposition reaction, this is our next one. So decomposition is almost the opposite of a composition reaction. This is when a complex substance, something like a compound, is broken down into 2 or more smaller substances. It doesn't need to break down automatically into elements, but oftentimes it does. And this happens when we heat it up or add energy to our compound in order to break it down. Right, so we're starting with one more complex substance like our picture shows. We heat it up, and then they separate into their parts. All right, so our examples for a decomposition reaction, right, we have potassium chlorate. This is a compound that contains the element potassium, chlorine, and then 3 oxygens. And when we heat this up, it separates into, right, 2 smaller things, a potassium chloride and oxygen. We'll talk a little bit, we have like a little cheat sheet for you on how to identify these, and that will make things a little bit more clear at the end. Right here we have a compound, calcium carbonate. Right, this calcium carbonate has a calcium, Ca, 1 carbon, and 3 oxygens. We heat it up, that's what this delta H right here means, and we end up with calcium oxide plus CO2. Right, it didn't produce elements, right? It didn't break this into calciums, carbons, and oxygens, but it did make it into smaller, more complex substances. All right, so when I think of a decomposition reaction, I usually think of compost, right? So Think of like a banana peel or an apple. If you leave it outside for a long period of time, it starts to decompose and break into its smaller parts. Our next type of reaction is a single replacement reaction. This is where one single element takes the place of another element in the compound. I like to call this the Trey Songz of chemical reactions. I'm not sure if you're familiar with Trey Songz, but his nickname is Mr. Steal Your Girl. Right? And in this example, this element, right, our green element that we have here in the picture, is going to come in and steal the other element, right, and kick one out. All right, so our examples here, we have zinc, which is Zn, plus hydrochloric acid, HCl. And after reacting those two together, we'll get a zinc chloride compound, and it kicked out the hydrogen, right? You can see how the zinc comes in, kicks out the hydrogen, and steals the chloride, right? The zinc was Trey Songz in this example. Our next example, we have copper, Cu, plus silver nitrate. This is a very cool looking reaction. We'll probably do this one in class. And what happens here, right, the copper comes in and kicks out the silver, and we're left with silver plus copper nitrate, right? The NO3 is our nitrate. All right, so that is a single replacement reaction. Sorry about that. Let's take a look at a double replacement reaction. So double replacement is similar to a single replacement, except we're looking at two compounds here. There's no element, right? Two compounds. And what's going to happen, there's two ions and two aqueous compounds, and they're going to swap partners. Right, so you'll take a look. We trade partners, and now we have new products. So our examples for the double replacement reaction, right, we have silver nitrate, AgNO3, plus sodium chloride, NaCl. And you look, we'll swap partners, so we should end up with, right, silver chloride and sodium nitrate. I don't know if you remember from algebra class when they taught you how to do what's called the FOIL method, the first, outers, inners, last when multiplying parentheses together. But I like to think of double replacement reactions as that OI part of the FOIL. Right? We're putting together our outers and our inners. So we're ending up with our outers, silver chloride, and our inners, sodium nitrate. Our next example is calcium chloride plus potassium nitrate. Why don't you try to predict what our products would be here? All right, and we end up with potassium chloride, right, plus calcium nitrate. We have our outers, our calcium nitrate, and our inners, our potassium chloride. Alrighty, so that is our fourth type of chemical reaction. Let's take a look at our fifth. All right, and this is my favorite, also my least favorite, and we'll talk about that a little bit more. But this is a combustion reaction. We've talked about the downsides of plastics, and a lot of that had to do with, right, combustion reactions in their products. So a combustion reaction is when a hydrocarbon, right, and a compound containing carbons and hydrogens, and it only has carbons and hydrogens with single bonds, reacts with oxygen to produce water and carbon dioxide. Right, that should sound familiar to you because we've talked about this before. Right, and these give off a large amount of heat. Right? These combustion reactions, right, power a lot of our energy, whether that's our automobiles to get to school, heating your house, or charging your phone. Right? A lot of these come from combustion reactions. Our first example, we have methane plus oxygen, and that produces water plus carbon dioxide plus heat. Our next example, right? This is an alcohol plus oxygen, right? This is not an alkane, right? And it produces water plus CO2 or carbon dioxide plus heat, right? It has the same products, and they will always have the same products for combustion reactions, so that's a good way to memorize or identify these. And what we will do to complete those is balance, and we'll get to that later on this week. All right, so let's do a little review here. So I have 5 different pictures of chemical reactions, right? And you are going to identify what type of reaction those are. So remember, we have a synthesis reaction, also known as composition. We have a decomposition reaction, a single replacement reaction, double replacement reaction, and a combustion reaction. Alrighty, very good. So hopefully that helped. This next part is going to be huge. So make sure you're paying attention when we're going through this, and make sure when we're practicing or studying for your quiz, this is the part that you want to be looking at here. All right, so when we look at a chemical reaction, right, unless you're somebody that's been teaching a chemistry course for several years, like Mr. Arrow or myself, it's not super easy to identify. So we're going to look for certain hints. So if we have a combustion reaction, your reactants are always going to be a hydrocarbon plus oxygen, and that's how you're going to identify it. So if you see a hydrocarbon or something with H's and C's plus O2, we know we have a combustion reaction. Right, so you're looking for C's, H's, and O's in your hydrocarbon, in your reactant side. And remember, the reactant side is the left side of the arrow. If it's a decomposition reaction, you'll see you have a compound by itself, no plus sign, right, on the reactants. Right, you might see a plus sign on the products, but not on the reactant side. Right. Another thing that might tip you off that you have a decomposition reaction is if on the reactant side it says plus heat. Right, that's another way. It's not always, but it definitely is a hint to point you in the right direction. If we're looking at a single replacement reaction, okay, single replacement reaction will have an element plus a compound. A double replacement reaction will see a compound plus a compound. Alrighty, and then if it's not one of those, it must be a synthesis. So a synthesis would be, right, two smaller things or something plus something, but your products, and this is going to be where you identify it here, it should only have one compound, so there should be no plus sign on the product side or the right side of the arrow. All right, so make sure we have all of that down. All right, very, very important that you have it there. And now I see down at the bottom underneath it must be synthesis. You see where it says balancing chemical equations? That's where we're going to start our next Chem Talk. All right. Thank you for sticking through this with me. Before you are done for the day, you also need to work on the Chem to Go Part 1. That is on pages 13 and 14, and I want you to finish that whole thing. Alrighty? And we will check your work when you are back in class with us soon. Alright, have a great rest of your day.